All right, the second part says Nokia EDA brings simplified data center networks. Now, this is a very interesting take. So what simplified means is we all play with the same components, right? We may use different vendors, we may use different operating systems, but in a nutshell, it's all interfaces, MAC VRFs, IP VRFs, BGP groups. Based on standards, we kind of get to leverage the unified set of building blocks that we build our networks off. But at the same time, this is just the building blocks. The complexity comes how to glue those building blocks, how to make sure that if you go from one version to another, the building blocks continues to work, or God forbid you go from one vendor to another, the building blocks are the same, the implementation is vastly different. So that is why simple is hard. Although it's very simple to say something very basic like configure the MTP, reality kicks in. There's a lot of things that a system needs to do, or you need to do if there is no such system. You need to parse and validate the input. You need to identify which nodes you want to deploy this MTP on. You need to make sure that you push the config reliably. If something fails, you roll back, and you roll back from the whole change that you initially wanted to deploy it on. You need to display the state, like if you deploy the MTP, is it synced? If I just deploy it and I don't know if it's working or not, what good does it do to me? I need to have this constant loop of state retrieval, the monitoring, ensuring that I see the health of my component. We need to monitor the deviations. If somebody goes in and changes the MTP server, if I do not know, then my original configure MTP intent is completely broken. So there's a lot of things one needs to ensure for a simple thing like configure MTP. So what we think can be a remedy, a solution, a magic pill that can, if not solve, then vastly simplify the thing is what we call declarative abstractions. So declarativeness means that we define what we want to deploy and not how to do it. Instead of saying, I go to enable candidate, configure MTP server, blah, 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 with this particular syntax, I say what I want to create. I say MTP client on the router management instance with this particular server IP address, and that's it. And there is no vendor-specific thing that I use here, right? The intent, I know the word is typical, but for the lack of the better word, the intent is quite simple and abstracted. It does not really ask you how to do that. It asks you what you want to create. And this, of course, assumes that there are meaningful defaults. So you want to hide implementation details for different vendors, you will have to, right? If your intent is abstracted and it does not show these nerd knobs from different operating systems or different little nerd knobs in the configuration tree, you just need to assume some defaults or hide them. It also means that as higher you go in the abstraction tree, you lose the granularity. If I would say, instead of having an MTP client as an intent, I want to have a client, I want to have an intent, the best router in the world, it means I will hide a lot of complexity from you, but I will, of course, hide also the implementation details. You will not be able to fine-tune it the way you want. So there is always a balance between the fine-tuning and abstraction level. All right, so now let me actually switch to my installation. We completed the installation. The last line says EDA is launched. So what I hopefully should be able to do is to use this URL that is presented on the penultimate last line and see the UI, right? So that is what I want to do right now to make sure that we are on good terms with my machine. So I will use this devbox netdevops me 9444. You see, that's expected. That's because I need to refresh. Okay, so I'm accepting all the risks of today and launching the EDA. So this is what you will get when you start with EDA, right? You get the admin as your default credentials. To log into the system, I will remind you that it all runs on my machine that I just deployed. So it's not pre-canned installation. I just did it while I was talking about the fancy MTP configuration. And here you see what you get as part of the dashboard. The first screen that you see shows you the overall view of your cluster. Right? I have 3 nodes. These 3 nodes, in the meantime, have all been synced. The synchronization means that EDA onboarded the nodes, installed TLS certificates, installed the user, made sure that we all use fully secured TLS when we talk to the nodes, and it also enacted the configuration on the nodes. And one thing that probably I want to step here and emphasize, so EDA is an enforcing source of truth. It does not just connect to the nodes. It actually configures it from the ground up. It means that whatever is not in the system will be considered a deviation. So EDA, what it has in its configuration is a pattern that it says, I rule how my network looks like. Whatever you configure here will be on the nodes. Whatever you configure out of band will be considered a deviation, and you should not do that. Okay, so this is what you get, right? This is the UI. You, of course, have the navigation panel. Hope you can see it clearly. On the left-hand side, there is a navigation panel, and it has a lot of things in it. There's a lot of interesting components like default BGP groups, default routers, fabrics, aggregate routes, overlay configuration like VNets, IRB interfaces. What are we looking at is what we call an EDA application. EDA is an extensible system, and we will install some additional application, and you will see how you can make it all work. But this on the left-hand side is the units of automation. That's how we call them. We will create a bunch of interesting things with you today, but what I want you to keep in mind is that these applications will be open source quite soon. So you will be able to see how exactly we create a BGP peer out of the intent, how we create MAC VRFs, bridge domains, and some complex components like fabrics, for example. So stay tuned for the open sourcing part. Today, we will just focus on how to use these things, right? Now, we also can access the nodes. Remember that I said that we deployed the digital twin. There's 2 leaves, 1 spine. That's part of my topology. So I will have to do one little thing here. I will show you how you can connect to the nodes, because when you play with EDA, of course, you will use a few UI tricks. You will configure things in the UI, but you also want to connect to the SO Linux nodes and see, hey, how is my configuration actually being provisioned? I want to see the real deal. I don't trust the flashy UI. So that is why when you are in the playground directory, there are a bunch of make targets that simplify connectivity to your devices. So when I'm in the playground directory, I can say make leaf1 SSH, and this target will connect to the Kubernetes cluster, find the leaf pod, and will open an SSH session to it. So Nokia SRL1 exclamation mark is the password. And as you can see, I'm in the shell of my SRL Linux. Show version, we are running the latest and greatest 8532, and this is my IXR D3L. Okay, so very easy for you to connect to the nodes. It's all part of the same setup. You don't have to deploy it on the side. You can use ContainerLab with EDA as well, if you're familiar with the tool. But CX, or this digital twin, makes it really easy to bundle components together, so you don't have to even worry how to create it. So I have these 3 nodes. I can also have a look at my topology here in the EDA UI. So there's topologies application. You click on this, and this is my physical topology, exactly how I explained. 2 leaves, 1 spine, all green, running, synchronized. That means that we are good to go. All right, so we will talk about resources quite a lot. We will use the term custom resource, which comes directly from Kubernetes to us. This is the term that they use. What custom resource, or just a resource, means is a way for us to declaratively define an entity, a thing, in EDA. Same way as you define a pod or a service in Kubernetes, we can define everything in EDA using custom resources. So what you look here at is the NTP client custom resource. This is the real thing. It's not on the previous slide, it was just like a simplification, but this is the real resource that you can submit to EDA for it to enact an NTP client on the nodes. You see, I broke it down to 4 different components, right? There's component number one, which specifies the API version and the kind. This is like a green circle with number one. This is very cool because now you have a clear separation of which API you use to create this client. If we were to advance this client to version 2, the API version will, of course, change to /v2, and that means that you are using a different API version. Versioning of APIs is super important if you want to have a reliable automation system. You need to know which APIs and which versions you use, and these two lines, the group, version, and kind, which are colored in different colors in the first two lines, they uniquely identify the resource. There is a group, timing.eda.nokia.com, that NTP client comes from. There is a version, v1 alpha 1, and there is a kind, what kind of object we are trying to create. With block number 2, there is a metadata block. In the metadata, you typically specify the name of the object and the namespace it belongs to. And we can also have annotations exactly the same as in Kubernetes. The third block is how you configure or how you define your object. This is a specification. We'll call it spec for short, but this is exactly what makes this object, fills it with configuration data. So we say there is a router that we'll use that this NTP client needs to be created in, management router. We'll use the management VRF for that. And we will use a list of servers. I only have one. This is the server that we will use. And then lastly, remember that we talked about the state. So state is important to get from the resource that we create. Once we create an NTP client, we want to see, is it actually synced? Maybe I use the wrong IP in my NTP client, who knows? By having the status field of the resource, you get the ability to get the state out of the system. When it was last changed, what is the operational status, how many nodes it was deployed on. All of these things can be put in the status. I will remind again, it's all configurable, tunable by you. It's not a black box that we offer to you. You will be able to look at the code, see how we populate the status. You will be able to fork this, make your version of the NTP client. So it's kind of sky's the limit for you. If you know a little bit of Python, you will be able to see what it is and how it works. We have an NTP demo. It's fantastic. So what I will do in the NTP demo is I will create this NTP client with you, right? I want to make sure that we can actually make use of the platform. So what we do here is, remember there is the application somewhere here, NTP client. You can just scroll in and see where it is. I prefer to use the search, it just makes it easier. So I know there's an NTP clients application here. How do you create things in EDA? Well, it's not that hard. You select the application and you see an empty screen. Not really helpful. What it means is that you don't have any NTP clients right now. When you created the the EDA Playground platform, there's nothing in it, just basic configuration to onboard the nodes. There is no configuration on the nodes. And actually, it actually makes sense to show you that you can see the configuration of the nodes right from the platform. You don't need to dive into the CLI. You can just open the nodes application, select one of the, I think I need to make it bigger so that you guys see it better. You can select one of the nodes, click on this vertical bar, node configuration, and this is your running config. This is what is enacted on the boxes, right? So you see there's basic stuff, just network instance management with DHCP to get my IP address from the DHCP, and then some LDP config on the interfaces that make up our topology, but no protocols, no NTP clients, nothing like this. And now what we will do, we will create this NTP client. So yeah, we will go to the NTP client. This is the application that we'll use. We click on create. This is how you enter to the configuration dialog. In this configuration dialog, you see there are three main panels. The panel on the left is just the table of contents that helps you navigate quickly. The central panel is the form, and the right panel is the YAML version of this form. We'll use a lot of YAML here, not to scare you off. It's just, when you do some automation, you already use YAML probably like day in, day out. Now I will create an NTP client. I will call it something like my NTP client, for example, my NTP, and I have my source of truth here. This is helpful. You have to select the namespace, right? What is this? Namespace is the way for you to separate the resources in the platform. They can be used or shall be used for RBAC control. You can create different namespaces for different teams, and role-based access control rules will make sure that a team can only access one namespace, not the other. You can slice your fabrics into different namespaces. So this is kind of a way for you to slice your big network into the chunks and manage them more or less separately. I only have one, and you will only have one namespace by default when you install EDA. The namespace is called surprise EDA here. So I select this one. And then as I scroll down, I see more fields. I see the specification. You remember that I talked about the spec being the core of the resource. In the specification, this is where I set up my configuration of my NTP client. What router kind do I need to use for this one? The router kind, maybe it's quite interesting. Why router kind? Why not like a VRF or something like this? Again, we want to make sure that our intents are abstracted. The reason is that the platform will be multi-vendor, so we cannot use, or we shall not use, any specifics of our own, so Linux, for example, operating system. We want our intents to be abstracted so that you think in abstracted terms what means sense for the NTP client in general, and not on SO Linux specifically. So here we need to select the router or VRF where this NTP client will be instantiated on. It's going to be a management router because my NTP in the management VRF. And I also have this management router instance configured in my EDA system, which means I can select it here. Don't worry if you don't follow along how it all works. We'll dive into this a bit later. And then I need to select what server do I want to use, right? Because I have to select a server to connect to my NTP to. So I say I will use the iBurst, will be a preferred server. And I know that my NTP server is this IP address. It's part of my setup where I deployed my EDA system. So I click add. Nothing happened so far. I'm just creating the resource configuration. I do not talk to the nodes just yet. I'm just building this YAML file that I will use. And once this YAML file is ready, I can click commit, right? I click commit, and hopefully it all works. I just committed my object to the EDA system, and EDA did something, but I'm not sure if it's actually working or not. So now what can I do? I can go to my node, like you would do normally, right? And I can say info from state system NTP. And as you can see here, the NTP is there. It was not there before. The configuration was just basic management configuration of the nodes. But now the NTP is there on leaf 1. If I connect to leaf 2, I should be able to see something similar, right? Because the way we deployed the NTP client is that it will target all the nodes in my topology, which means both spines and leaves, both spines and leaves, yeah. So info from state, system, NTP, and I have this here as well. So it's upper state up, it's synchronized already. The one before was not, so now it's should be all good. So now it's all synced. All right, this is great. We just configured NTP client with an abstracted intent. We used basic YAML for it, worked brilliantly, but we need to go on, right? We have to do something more fun. We will talk about how we actually targeted all these nodes, because we did not specify IP addresses for the nodes. We did not say target leaf 1, target leaf 2. It kind of happened in the background, but what exactly did we use? What we use is a different ways that EDA supports when it targets the nodes. You can use a strict mechanism of targeting the nodes. You can say, I want to select leaf 1, leaf 2, spine 1. And that is what we call strict. It means that you need to handpick what nodes you want to configure your object on. It's granular. very good, so you can select what you want to configure, but it's not scalable. If you have 500 leaves, you don't want to click on each and every one of them. Just not practical. And it's static. It means that what you have configured is going to be just your selection. If a new node comes up, you extend your data center network and you have new leaves, they will not be selected if you just use the names. You need to edit your resource and add them back to the selection. That is why what is something better for these scaled out use cases is label selectors, right? When you tag your objects with labels, you will be able to use these labels and say, instead of taking in leaf 1, leaf 2, leaf 3, just pick up every node that has been tagged with a particular tag. So in this example, we are creating a banner application. This is your message of the day kind of thing on the nodes. And if you tag your nodes with a specific banner, you can select on this banner. And that means that every node that has been tagged with it will receive the configuration. Which is what is more even cool is that if you have another node that has been bootstrapped to the system and you tag it, it will automatically detect that it's live and configure this intent on the node. So it will be actually always constantly monitoring the nodes with a particular label, and when a new object with a label comes up, it will fire off the configuration of this node. So this is the labels demonstration that I wanted to give, but I think I will skip it because we will have more fun things to do with labels later. We also have the allocation pools. Now, you don't want to play with IP addresses manually. You don't want to go and have an Excel sheet with ranges and pick up IP addresses. Although we all did that, there is no shame in that. But you really want to have something that speaks more to automated way of requesting IP addresses, requesting indexes, requesting pools, something that you need to kind of maintain separately and make sure that you can reliably get these resources. In EDA, we have allocation pools, a concept that allows you to define IP pools, subnet pools, indices pools, and these pools will be holding the range of either networks or IP addresses, and EDA can request them from it, meaning that if you create an interswitch link and you want to address it with V6 point-to-point IP addresses, you really don't care which IP addresses there are. You just want to have 2 of them. So you can, instead of setting the IP address, you can just say, hey, take the address from the pool, and EDA will take it out and make it work. And before you ask, of course, there must be a synchronization with another source of truth. If you use Netbox, you have a Netbox app that allows you to sync these 2 concepts together, take indices from Netbox and subnet ranges from it, synchronize it with EDA's pools, and EDA will use these values.